Section 1.7 is on logarithms. So logarithmic functions are the inverse of exponential functions. So if I have an exponential function, y equals b to the x, and a log function log base b of x equals y, these are inverses of each other. Remember we talk about rewriting this log in exponential form? It would be b to the y equals x. You can see that that is the inverse of my original exponential. So anytime we have inverse functions, they undo each other. The range and domain of a log function, if I have log base 10 of, well, let's say y equals x, we'll do it this way. Then when I take the domain of this, oh, I'm sorry, let me do it the other way. Y equals log base b of x. Let me make it more general, okay? The domain of this function, the parent function, looks like this. So y equals log x would look like this. The domain here, we have a vertical asymptote as x equals 0, so x must be greater than 0. And that is the domain of any function. We cannot take the log of a negative value. Okay, so range and domain. The domain is therefore x is greater than or equal to 0. The range goes from negative infinity, and this continues to go up even though slowly, so this would be all real numbers. My pen skipped, I got an extra L in there. There we go, all real numbers. Okay, so domain and range of log functions. Properties of logs. If you remember, when you multiply the argument, the piece inside here is called the argument, we add the two logs. So if I have ln of 2x, this would be the same as ln2 plus ln x. I hope you remember that ln is another way of writing log base e. If I take the quotient of x and y, I'm going to use subtraction, and if I have x raised to a power, the power can come down in front and multiply. So these are our properties of logs. They are very similar to our properties of exponents. Don't put this in your notes, but just take a look. If I am multiplying two bases, and remember, exponents are the inverse, so if I am multiplying two bases, I end up adding their exponents. Multiplication and addition go hand in hand. If I am dividing, I am going to subtract their powers. And if I have something raised to a power, it really is multiplying 3 times. So a power becomes a multiplier. So they're not exactly the same word for word, but we can see how exponents and logs do have a relationship to each other. You don't have to put this in your notes. Okay, so how are we going to use these properties and things to help solve for logs? So there are a couple ways to look at this first one. Let's try it together. I can say divide both sides by 100 first. So now I have 1.03 to the x equals 3.75. This is an exponent, so I do need to take a log of both sides. So let's say ln of 1.03 to the x equals ln of 3.75. This x now can be brought down in front using my property of powers for logs. And now I get x equals ln of 3.75 divided by ln of 1.03. And if I put that in my calculator, I get 44.716. And it is an approximation because this decimal goes on and on forever. Let's look at this one. I'm going to use my rule about addition. So I'm going to say that this is ln of x times x squared, which is ln of x cubed equals 5. Bringing the power down and dividing by 3. So now I have ln of x equals 5/3. Again, remember that this is base e, so if I rewrite this as an exponential, e to the 5/3 equals x, and again putting this piece into my calculator. Oh, I didn't do this one. Hold on. I'll grab my calculator quickly. So I've got e raised to the 5/3 power, and I get approximately 5.2945. All right, so we're going to do some more of these in class before I start you off on doing your own work, but that's it for the video. This was a real short one, and that's great. That's all we have to do with logs, though, for right now. Oh, I'm sorry, change of base. I hope you didn't turn off the video. Change of base to use in your calculator. So if I have log base 3 of 7, in my calculator I'm going to put log 7 over log 3. And we will talk about that as well. My bad. All right, that's it. Now we are done, and you're finished with your notes.